Okay, students, a very good morning to all of you and welcome back to physics class 11th. So, as previously we were doing, we started with dimensional analysis. So, today we will be doing some problems and other applications of dimensional analysis. Okay. So, here we have a warm-up question to start with dimensional analysis. The question goes as, find the dimensions of specific heat, and specific heat C is given as heat per unit mass to the rise in temperature. It is given as heat per unit mass to the rise in temperature. So you need to find the dimensions of specific heat. You need to find the dimensions of specific heat. Chalo, let's go ahead and find these dimensions and then we'll move ahead with other applications of specific dimensional analysis. Chalo, please be quick. Please be quick. Okay. What will be the dimensions of heat? What will be the dimensions of heat? Now, what is heat? Heat is nothing but a form of energy. Heat is nothing but a form of energy. So it also belongs to which family? It belongs to the family of energy. Okay, yeah, good morning, Mita. It belongs to the family of energy. And we very well know that in the same family, the members have same dimensions. Members have same dimensions. So the heat will have the same dimension as that of energy. And what is the dimension for energy? It is ml square T power minus 2 or ml2 T minus 2 divided by mass. What is the dimension of mass? M. What is the dimension of temperature? Kelvin K. So what will be the dimensions of specific heat? The dimensions of specific heat would be, now m power 1. If it goes up, it would be m power minus 1. So total m power 0. Anything to the power of 0 is 1. We don't need to include that now. So we have L2 T minus 2 and K again goes into the numerator. So K power minus 1. I hope this part is clear to all of you. Yes, I hope this part is clear to all of you. Chalo. Now to go ahead with other applications, before going to next application, let us review the problem that I gave you yesterday as a homework. Okay, I gave you a problem as a homework yesterday. That was in the equation f is equals to a root of x plus bt square. In the equation f is equals to a root x plus bt square, we needed to find out the dimensions of a is to b or a by b. We needed to find out the dimensions of a by b. I have been talking about the process, a concept that you need to remember while doing the problems for dimensional analysis, that if two quantities are added, they can only be added if they have the same unit or if they have the same dimension. Perfect. So over here, if you see a root x and bt square have been added, that means they have the same dimension, they have the same unit. If they have the same unit, you will add them, you will again get the same unit. That is, if suppose the unit of a root x is meters, and for bt square it's also meters. Why? Because they are added, that means units are same. So meters plus meters would again result in meters. Meters plus meters would again result in meters. That means the unit of f will also be meters. That means I can say that unit or dimensions of f are same as unit or dimensions of a root x and is equals to unit or dimension of bt square. Perfect. Unit or dimension of bt square. Fine. I hope this point is clear to you. What about f? What about the dimensions of f? So first of all, I equate these two, unit or dimension of s. What is the dimension of f? M L T minus 2. Dimension of f is ml t minus 2. What is the dimension of a root x? Dimension of a we need to find out. Root x. Now x is what? X is displacement. Displacement is length. So L power 1 by 2. Quite clear? L power 1 by 2. So what will I have a from here? I have a as ml t minus 2 divided by L की power 1 by 2. Now if this L की power 1 by 2 will go in the numerator. If L की power 1 by 2 will go in the numerator, it will be L की power minus 1 by 2. Minus 1 by 2. Here we have L की power 1. So net will be L की power 1 minus 1 by 2. That is L की power 1 by 2. So I will have the dimensions of A as n L power 1 by 2 into T की power minus 2. This is the dimension of A. This is the dimension of A. Fine. We need to find out A by B, the dimensions of A by B. So let us find out the dimensions of B now. Let us find out the dimensions of B now. So now I equate these two. That is unit or dimension of F equal to unit of dimension of BT square. So what is the dimension of F? Again it is M L T minus 2, which is equals to B multiplied by T square. Dimension of T, time. So T the power 2. Perfect. Now I'll get it this side. So the dimensions of B would be M L T minus 2 divided by T the power 2. Now this T the power 2 will go in the numerator, it will be T the power minus 2. So what will I get? I'll get dimensions of B as ML T the power minus 4. I'll get dimensions of B as ML T the power minus 4. So let us find out now A by B, dimensions of A by B. So dimensions of A by B will be, A is just, I have M L की power 1 by 2, T की power minus 2 divided by M, dimensions of B, it's over here, M L T की power minus 4. Fine. So here again it's M की power 1. If it will go in the numerator, it will be M की power minus 1. So M की power 1, M की power minus 1. Removed. I'll have removed. I don't take it. L की power 1. If it goes in the numerator, it will be L की power minus 1. So L की power 1 by 2 minus 1. So L की power minus 1 by 2. I'll have L की power minus 1 by 2. T power minus 4. If it goes in the numerator, it will be T की power plus 4. T की power plus 4 minus 2. It's T की power 2. T की power. So I have the dimensions of A by B as L की power minus 1 by 2 into T की power 2. Is this question clear to all the students? Please see. Students, is this question solution process clear to all of you? Please check and reply fast. Please check and reply fast if this question is clear to all of you. Hurry up. Okay, fine. So, if this is clear to you, most of you would have maybe found out answers yesterday itself when I gave you the homework, because it's an easy question. Okay. Now let's come on to another application of dimensional analysis. Now let us move on to other application of dimensional analysis. Dimensional analysis is a very, very, very useful topic. Okay. The other application is to check the correctness of an equation. To check the correctness of an equation. When did you say that an equation is correct? When will you say that equation is correct? Remember, you say an equation is only and only correct if the dimensions of LHS are equal to the dimensions or units of RHS. But of course, you cannot say 2 banana equal to 2 apple. Is it possible? No. 2 oranges equals to 2 mangoes. No, they are not equal. Only the magnitude number is equal. But they are not the two same physical quantities. So if an equation is there, so LHS of the equation, left hand side of the equation is equals to RHS side of the equation only and only if the units or dimensions of LHS are same as the units and dimensions of RHS. Okay, so let's check the correctness of Newton's first equation of motion, which is V is equals to U plus minus AB. Let us check the correctness of equation V is equals to U plus minus AB. Okay, where V is the final velocity, U initial velocity, A acceleration, and T the time. Fine, chalo, let's go ahead. For final velocity V, what will be the dimension or unit? It is meters per second. Okay, or I can say meters second inverse. So the dimensions would be L T minus 1. Quite clear? Let us go ahead with initial velocity U. For initial velocity it would be, or for RHS, I have LHS, I have RHS. Okay, LHS and RHS. So for RHS, it would be meters per second plus minus acceleration is meters per second square multiplied by T seconds. Okay, so seconds and second one gets cancelled. So I am left with meters per second plus minus meters per second. Now meters per second plus minus meters per second would be what? Meters per second only. Whatever amount you will get, but the unit will be meters per second. See, 4 meters per second minus 2 meters per second results into 2 meters per second. 4 meters per second minus 2 meters per second results into 2 meters per second. The unit remains the same. So now I can write here, it would again be meters per second. So what will be the dimensions for this one? This would again be L T minus 1. So that means LHS, the dimensions of LHS are equal to the dimensions of RHS, and hence we say that equation is correct. Equation is dimensionally correct. Is it clear to all of you? So students, is this part very much clear to all of you? Please see. Is this application clear to all of you? Please check. Hurry up. Is it clear to all the students so that we move ahead? Yes? Students, please check. Okay, chalo. So I'll go ahead with another question, and this you need to do. Okay, this question now you have to do. The question says, check the correctness of equation v square is equals to u square plus minus 2as. Newton's third equation of motion. You need to check the correctness of v square plus v square is equals to u square plus minus 2as. Quite simple process. Again, what do? You'll find out the dimensions of LHS. You'll find out the dimensions of RHS. If these both are equal, then the equation would be termed to be dimensionally correct. So let's go ahead. V here is the final velocity, U again is the initial velocity, A is the acceleration, and S is the displacement. And S is the displacement. Chalo, go ahead please. These questions are very simple. The only thing is that you need to be very careful in addition and subtraction. That is कि छोटे क्लासेस का काम बड़े ध्यान से करना है. Addition, subtraction, multiplication, division. That's all. If you are able to do that comfortably, the problems are very simple. And please share what is the dimension you got in LHS. Please share what is the dimension that you get for LHS or RHS, whatever. Okay, Ashutosh has come up with the answer. Ashutosh, I also want to know what is the dimension that you get. What is the dimension that you get? Please share that also. The dimensions that you get. Okay. L2 T minus 2. Ketan, why M by A? Where does this A come from there? A is not going to play any role. Come on. L2 T minus 2. Yes, it's correct. It should be L2 T minus 2. Okay. See, it's simple. We have V square. I'll move ahead with LHS. We have V square. Velocity V is given as meters per second whole square. Right? So it would be meters square per second square. So its dimensions would be meters is length power 2, seconds is time, t की power minus 2. Second square, if it goes up, it would be minus 2. For U is again meters per second whole square plus minus twice. I don't need to take the unit for a number, for a constant. A acceleration is meters per second square multiplied by seconds. Quite clear? 2A meters per second square multiplied by seconds. Yes? Sorry. S over here was displacement. So it would displacement is also length. So now I'll get meter square per second square plus minus meter square per second square. Because S was displacement. This is what many students face a problem. Okay. So now meter square per second square plus meter square per second square would result into meter square plus by second square. So what will be the dimensions? It would be L2 T minus 2. And we have LHS equals to RHS. That means the equation is dimensionally correct. So now this application is very much clear to all of you. Let's move on to the third application of dimensional analysis. Let us move on to the third application of dimensional analysis. And this application is very important because in competitive examination, specifically in JEE, as well as in NEET, you get problems from dimensional analysis of this form. Specifically, most of the times you get of this form. So please be very careful while studying this. Okay? Okay. Let's go ahead. The question says, first of all, I'll tell what is the application. Application is deducing relation amongst physical quantities. Deducing relation amongst physical quantities. With the help of dimensional analysis, we are very easily able to get the relation amongst the given physical quantities. And this you get by, if you have been given the dependency, कि a particular physical quantity is dependent on these factors. Okay, so let's go ahead and understand this part with a particular question. Okay, how to deduce relation amongst physical quantities. Okay, we'll do it by simply using the relations and the concepts that we have up till now studied for dimensional analysis. So the question goes as time period T of a simple pendulum. Please go on writing the question so that I can rub it. Time period T of a simple pendulum is dependent on mass m of the bob, length L of the pendulum, and acceleration due to gravity small g. Obtain a relation for time period t. Obtain a relation for time period t. This is a very simple question. This question has even been given in your NCERT. This question has been even given to your NCERT. So it's a very simple question to understand how to obtain a relation amongst the physical quantities. So I'll read the question and then I'll rub it and show it how to go ahead with the problems of this kind. So time period t of a simple pendulum is dependent, time period t of a simple pendulum is dependent on mass m of the bob, length L of the pendulum, and acceleration due to gravity g. Obtain a relation for time period t. So I need to obtain a relation for time period t. ठीक है ना? चलो, I need to obtain a relation for the simple pendulum's time period capital T. So I use the relation between these physical quantities. That's all. Okay. So what do you get to know? The time period t of the pendulum is dependent on what factors? It's dependent on mass, length, and acceleration due to gravity. Okay, it is dependent on mass, length, and acceleration due to gravity. And let us say it is dependent on these factors by powers A, B, and C. It is dependent on these factors with powers A. I think it's small, maybe visibility problem. A, B, and C. Fine. Okay. Now A, B, C can be positive, they can be negative. So if it is negative, it would be inversely proportional. If positive, directly proportional. So T is dependent on these. If I need to remove the sign of proportionality, I need to introduce a constant. Let us take a constant. So I can say T is equals to K M mass power A, length power B, and acceleration due to gravity G power C. This is what initially we get the relation. Now, if this has to be correct, if this equation or any relation needs to be correct, that means it needs to be dimensionally okay. It means it needs to be dimensionally okay. And this is already given, it is dependent on these factors. So dimensions of this should be equals to dimensions of this, the part of dimensions. Chalo. So what will be dimensions of time? T only. So I can say it to be T. Perfect. Now, for dimensions of M is the mass, so it would be M power A. I don't need to take K now. Why I don't need to take K? K is a constant, it would be a number. It won't have any dimensions or units. So M power A. L is the length. So I have L power B. Okay. And now again, acceleration due to gravity. So what is acceleration due to gravity? Acceleration, that is meters per second square. So meters per second square. So LT minus 2 whole power C. Acceleration is meters per second square. So meters is length upon time per square. So it would become LT minus 2. Perfect. Chalo, let's go ahead solving it. So I have T dimension over here. M की power A. I have L की power B and I have L की power C into T की power minus 2C. Quite clear? Yes? Is it okay now? Okay? So what do I get now? I'll come over here so that it is more clear to all of you. So now I'll solve this further. I have LHS as T itself, RHS which is M की power A, M की power A, L की power B plus C, L की power B plus C, and T की power minus 2C, and T की power minus 2C. So if you look at LHS and if you look at RHS, we can very comfortably get the values of variables A, B and C. So if you look at LHS, do we have M over here? Do we have M over here? We don't have. So if you don't have M over here, that means over here also M should not be there. M should not be there. But that doesn't mean M should be 0. No, M should be 1. M should be 1. Right? Because here M is not there. So here also M should not be there. So M should be 1. How it will be 1? That is what I get? I get A is equals to 0. Very clear. A is equals to 0. Now again length is also not there. Again length is also not there. So again I'll have now B plus C is also equals to 0. Quite clear? B plus C is also equals to 0. Yes? So what I'll get then again, let us compare T. So here T is having power 1 and over here T is having power minus 2C. So therefore minus 2C is equals to 1. Yes? So therefore C is equals to minus 1 by 2. Okay? Yes? A is equals to 0. I'll write it separately. We got A is equals to 0, equation 1. We got B plus C is equals to 0. This is equation 2. We got minus 2C is equals to 1. Minus 2C is equals to 1. So therefore C is equals to minus 1 by 2. This is equation 3. Yes. So if C is equals to minus 1 by 2, I can place this value of C in equation 2. So what will I get? B minus 1 by 2 is equals to 0. Therefore B is equals to 1 by 2. This is equation 4. So I got A 0, B 1 by 2 and C minus 1 by 2. Yes, we got A1 by A0, B1 by 2, C minus 1 by 2. So let us place the values of A, B and C. A, B and C in the initial equation that we took in this equation. Okay, so let us put, so I have T is equals to K, M की power 8, A is 0. So M की power 0 multiplied by L. L की power is B. B is 1 by 2. 1 by 2 into G. G की power is C. C is minus 1 by 2 into G, which is minus 1 by 2. Okay? Yes. So what will I get now? I'll get M की power 0 is 1. Let us remove it. So I'll get T is equals to K. L की power 1 by 2. G की power minus 1 by 2. I can write it as G की power 1 by 2. Perfect. So now I can write it as T is equals to K under root L by G. So this is the relation between time and other depending factors which were given to you. I hope this equation, this expression you might have studied also in class 9th, maybe this expression. So you see how I obtained this expression dimensionally. Is this clear to all the students? Students, please check, is this clear to all of you? Yes, please. Students, is this clear to all of you? Please check. Okay. So if this part is clear, I'll give you a question for homework. Please write down that question and then we'll end the topic for the day. Tomorrow we'll just be doing just questions on dimensional analysis. Okay, we'll do some competitive examination questions also of JEE. So let's take down a question. The velocity v of a water, the velocity v of water depends on velocity v of water depends on wavelength lambda, density rho, wavelength lambda, density rho, and acceleration due to gravity g. Velocity of flow of water depends on wavelength lambda, density rho, and acceleration due to gravity g. Obtain a relation for velocity v of water. Obtain a relation for velocity v of water. Okay, so this question you need to solve. We'll meet tomorrow with more questions of competition. So concepts are clear, the concepts will be same. So please review once again. Before coming to tomorrow's class, please review once again. Okay, thank you very much. Have a nice day. Enjoy your day. Be safe. Stay at home. Thank you.